All right, guys, we are going to quickly go over some problems for solving triangles. This is using our right triangle trigonometry, so we're going to be working with sine, cosine, and tangent. So one thing we talked about is an acronym for sine, cosine, and tangent, so we remember what function we're using. So SOHCAHTOA is our acronym we're going to be working with. We're going to use sine if we're working with opposite and hypotenuse. We're going to be working with cosine if we're working with adjacent and hypotenuse, and tangent if it's opposite and adjacent. So I've got two problems for you. The first one we're going to solve for a side. The second one we're solving for an angle. So let's look at the first one on the left. We are solving for side A. So this is what we are looking for right here. All right, so if you are following along with me, you want your scientific calculator out. We are going to be using the sine, cosine, and tangent buttons here. One thing I want to talk about before we do this problem, I don't know if you can see this, but right here in the corner it says DEG. That means we're in degree mode, so our angles we're going to be working with are going to be in degrees. We'll talk about this in a few weeks. There's actually a different unit for angle measure, which is called radians. So if that says RAD up there, you're in the wrong mode. So quickly how to change it if you are in radians, you're going to click mode. If your calculator is a little different than mine, there's always a mode button somewhere on it. So if you can see, once I open this, you see we have degree, grad, or rad and grad. Don't worry about grad. We will be working with radians in a little bit. So make sure it's highlighted on degree, press enter, and then you can go back to your home screen. Okay, so that's just kind of the setup. And then go ahead and locate where your sine, cosine, and tangent buttons are, because we're going to be needing those in a little bit. All right. So let's go ahead and set up our equation. So we are looking for A. We are given this side here. This is our hypotenuse, and we're given our angle here. Okay, so from this angle, A is the opposite, and 10 is the hypotenuse. 10 will always be the hypotenuse. Okay, so thinking about we want opposite and hypotenuse, that is saying we want to use sine. Okay, so we'll do sine. And in this sine function, we're going to use the angle. So 36 degrees equals our opposite, which is A, over the hypotenuse, which is 10. So that's the setup. So the things that could change, this could be cosine, this could be tangent, and then the placement of our variables. Now, I like to treat this like a proportion. So if you put this over 1, now you can cross multiply. So 1 times A, that's just A, equals 10 times sine 36 degrees. Okay, so now we've solved for A, but what is this? So this is where your calculator comes in. So we want to do 10 times sine 36, and then I like to close my parentheses and then press enter, and you get this decimal. So 5.8778552523. For this problem, depending on the instructions, it's going to probably ask you to round to the nearest tenth, maybe nearest hundredth. We'll round it to the nearest tenth, so we'll call it 5.9. So A equals 5.9. Most of the time there'll be units. There's no units on my problem, so we'll just kind of end it with that. There is a unit measure, add in inches, centimeters, whatever is the length of your sides. Okay, now finding an angle, it's going to be very, very similar to solving these equations. You still want to figure out what you have given and what trig function you're going to use. For this one, we have our angle. That's our unknown, but we need to use it with our ratio. Okay, we have this side 12, which is the opposite, and we have this side 10, which is the adjacent. Okay, so opposite and adjacent, that's going to be our TOA here, a tangent. So let's do the setup. Tangent of theta, theta is our unknown, that's what we're going to be solving for, equals the opposite over adjacent. Okay, this problem works a little bit different because our unknown is inside the function. Remember, I said this earlier. It's not tangent times theta, it's tangent of theta. Theta is the x value, it's the input. So we need to undo the tangent function. Okay, we talked about inverses before, so we need to undo the tangent. So there's something called tangent inverse. So it looks like that. It's also called arctan. So sometimes on some calculators they'll say arctan. If you're into the IB curriculum, I believe they like to use arctan. It's the same thing. But we're doing the inverse. So what that does is allow the tangent inverse and the tangent to undo each other. So then all you're left with is theta. But whatever we do to one side of the equation, we've got to do to the other. So we'll do tan inverse of 12 over 10. All right, so these cancel. We're left with theta, which is awesome. But now we're left with this whole tangent inverse of 12 over 10. Guess what? Now we just use our calculator. So again, notice we've got the tan inverse right there. It's in the highlighted green. And this is how most calculators like to do it. So what you're going to do is you're going to press the second and then the tangent button. So you see how it shows up in your calculator. And then you're just going to input the ratio, the 12 over 10. So 12 divided by 10, parentheses. So see how that got inputted? Press enter, and then our angle is usually, with angles, we round to the nearest whole degree. So that would be 50 degrees. Again, it might say round to the nearest tenth. If that was the case, it'd be 50.2 degrees. But whatever the instructions say to do. But usually what the work we do, angles are rounded to the nearest degree. Side lengths are usually to the nearest tenth. So if it doesn't say, that's kind of the general rule of thumb I would work with. Okay, I hope this was helpful. If not, write down any questions and we will go over it in our live sessions. Thanks for watching.